Hello, this is Ben McGahee with McGahee Mathematics, and in this video on polynomials we're going to learn how to divide polynomials. So we've learned adding, subtracting, and multiplying polynomials. Now we're going to learn how to divide polynomials, which can be one of the most challenging operations that you can do with polynomials. So let's look at an example where we get to divide two monomials, and then we have to simplify. So let's say if we have 20 x squared y cubed over 5 x y squared. So we have two monomials. We have 20x squared y cubed, and the other monomial is 5xy squared. So when we divide the polynomials, we basically divide each part separately. So we divide the 20 divided by 5 first. And then we do x squared divided by x. That's for the variable x. And then for the variable y, we have y cubed divided by y squared. Okay, so that'll equal 20 divided by 5. That's going to be 4. And then x squared divided by x, what we do when we divide, instead of adding exponents like we did when we multiply, we have to subtract them. So this will be 4x to the 2, and then minus, this is x to the first power, so that would be a 1. So x2 minus 1. And then for the y's, we have y cubed divided by y squared, so that'll be y3 minus 2. And so simplifying, we're going to have 4 x to, let's see, 2 minus 1 is 1, and then y 3 minus 2 is also 1. So 4x to 1, y to 1, which is also the same thing as 4 x y, because x to the first is x, y to the first is just y. So we have 4xy. Your answer. Okay. Another example that we'll look at is we'll divide a binomial by a monomial. So let's say you have 44a squared minus 33a all over 11a. So when you're dividing a binomial by a monomial, you're just going to divide each part separately and then subtract the two parts. So that will be 44a squared all over 11a minus 33a over 11a. And so this equals 44 divided by 11, that's going to be 4. And then a squared over a, that's like a to the 2 minus 1, just like we did last time. Because remember, this is a to the first power, and then we subtract the exponents. And then we'll have minus 33 divided by 11, that's 3. And then a to the first power over a to the first power. Since these are exactly the same, we can just cancel those out and we'll just have 3. So this will simplify as 4. A to the 2 minus 1 is just a to the first power, right? 2 minus 1 is 1, or just a, and then minus 3. So our final answer is 4a minus 3. Okay. Also, let's look at kind of an example where you do division and there is negative exponents involved. And let's see how to resolve those kind of problems. So if you have, let's say 56 k to the 4th m to the negative 8, and then all over, let's say you have 8k to negative 3 m to the 10th. So what we need to do is we do kind of like what we did last time with dividing polynomials. You may ask yourself why we're doing it with the negative exponents. You know, that's a good question. Is because usually polynomials don't really have negative exponents. But since we're dividing, we're kind of have a combination of parts that kind of represent polynomials, and then other parts that don't look like polynomials. But in the end, we'll have something that looks like, hopefully, some kind of division with polynomials once we are simplified. But on the surface, yep, with this term, m to negative 8, k to the negative 3, since they're negative exponents, they don't look like polynomials right away. But let's just see what happens when we do some simplifying. So what we'll do first is we'll do 56 divided by 8. We take care of the numbers first, so that will give us 7. So that will be k to the 4th m negative 8 all over k negative 3 m to the 10th. So now there's a rule in algebra: when you bring a negative exponent, if you move it to either the top or bottom, it switches the sign of the exponent. So let's say the k to the negative 3. If I want to make that negative 3 become positive 3, I have to bring it up top in the numerator. And then likewise for m to negative 8, I have to bring this down in the denominator to make it m to the positive 8. So when we do that, we'll have 7 k to the 4th times k to the 3rd, or k cubed, all over, we bring the m to the 8th down, so that'll be m to the positive 8, m to the 10th. And now when we simplify here, you know, we have the k's, so we just basically add the exponents together. And so when we do that, we'll have 7k, the 4 plus 3, add those together, all over m, and then 8 plus 10, and just add those together, equals 7k 7k, 4 plus 3 is 7, all over m. Let's see, 8 plus 10 is 18, so we have 7k to the 7th over m to the 18th. And that would be our final answer. So notice that we still have a fraction here, but we still got two polynomials that we're dividing. We have 7k to the 7th polynomial and m to the 18th. That's also a polynomial. So that's just how you resolve negative exponents. Just when you move it to either numerator or denominator, you change its sign, and then you collect the exponent with the like variables. So it's kind of the first part of the video on dividing polynomials. The next part will be where we divide the trinomials by binomials and even some higher polynomials by long division. So we'll see how that works. This has been McGahee with McGahee Mathematics. Stay tuned for the next part on polynomials.